Hi everyone and welcome to my poster presentation for EPS. And I'm going to be talking about the PhD work that I've done at the University of York. We've been interested in how schema influences our behaviour for schema-relevant and irrelevant information in the context of memory and generalisation. Now for the purpose of the poster, there's a lot of content to cover, so what I wanted to do was skip over some content, but do feel free during the Q&A session to ask me any questions about content that I have or haven't discussed explicitly. Now let's jump right in. We know from previous research that schemas can be formed through co-occurring patterns across events, and these can enhance memory recall and be used for generalization to novel instances. What was less clear, though, was how schemas could impact irrelevant information. Now, irrelevant in this context refers to items that the schema simply doesn't relate to. So we had three primary aims. But for the purposes of the presentation today, I'm only going to be focusing on 2 and 3, which were to examine how this schema could influence generalization and influence how they generalized for irrelevant items. So what we did was use the continuous retrieval paradigm, whereby participants would learn word location associations around a circle, and these words would come from one of two word categories, either human-made or natural. Now, one of these word categories would basically be assigned to a clustered condition, meaning that locations are much more likely to appear in one area of the circle than anywhere else. And the other would go into the non-clustered condition, meaning that these words were uniformly distributed in terms of locations around the circle. Now, what we did is we got participants to learn word location associations around the circle during study, but during tests, they were presented with old items, so these items where they have explicitly been given a location, and we also gave them new items, or generalization trials, where these are items that still fall within the two word categories, but were not explicitly given a location. And what we were interested in is how they would generalize for both clustered and non-clustered items. Now, for the purpose of the poster presentation, what we've done is we've actually collapsed the data into one large data set of 261 participants. And what we found for generalization was that when comparing to the von Mises distribution, which is the pattern underlying the cluster, we found that the clustered generalized items were much more similar to this than the non-clustered, suggesting that participants had extracted and were capable of using this pattern information for novel inferences or generalizations. But what was interesting here is you can kind of see this behavior here representing the non-cluster condition, and 0 here represents the center of the cluster. You see that as we get closer and closer to the center of the cluster, non-clustered items will be avoiding it rather than being placed uniformly, which is represented by this dashed line here. So we investigated that a bit further and found that participants would actively avoid placing locations at the center of the cluster when it was a non-clustered item. So these results seem to suggest that schemas can impact both relevant information, i.e. clustered information, but also irrelevant information or non-clustered information, suggesting schemas have influence on information that is not pertinent to themselves. I would like to thank you for listening and feel free to ask me any questions during the Q&A.